All right, so today we're going to talk about box plots. A box and whisker plot, or a box plot, is going to be used to talk about a data set. They're really great for comparing data sets when we want to have information about center and spread, symmetry, skewness, things like that. When we're talking about box plots, we're going to be making what's called a modified box plot in AP Statistics. A modified box plot is going to also show us any values that are outliers. A box plot looks something like this over here on the right. And uses something called the 5-number summary. Now, the 5-number summary is the minimum value and the maximum value of a data set, the very largest and smallest. The first quartile, the median, and the third quartile, which we've talked about a little bit before. But basically what we're going to do is we're going to divide the data into fourths. So we're going to divide it in half. That gives us the median. And then we're going to cut each half in half to get quarters. The first quartile is basically the 25th percentile, and the third quartile is basically the 75th percentile. Now over here, you'll also notice that on the graph, just like any numerical graph, we're going to have a variable label and we're going to have a number line that is scaled. On this picture, I have two outliers, which we're going to talk about how to calculate in this section. And then this is labeled as the minimum on this end of the whisker. I just want you to know that is the minimum value, that is not an outlier. The actual minimum value of the data set is that value 0. That is our very smallest number. The other thing we see is we have a box that runs from quartile 1 to quartile 3. That is the middle 50% of the data, which also gives us our interquartile range. The median is drawn as a single line to the middle of the box, and then we have a whisker out to our maximum value here. So this is what a very nicely constructed box plot tends to look like. All right, so on the next page, in order to be able to find a box plot, you've got to be able to find a median. Now, you've learned about medians in other classes. Basically, you always want to start off by first putting your data in order. If your data is not in order, then you can't count over to the median easily. It's always the single middle value if you have an odd number of values, or the average of the two middle ones. For example, students were asked to estimate the incline angle of a ramp leading up to a loading dock. A sample of responses is given below. Find the median for each class. So I've already done this, but I went through and I reordered my numbers. I noticed that 59, 49, 64, those are not in order. And so I have reordered them from least to greatest, 45, 49, 49, etc. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has a sample size of 9. So I should be able to find the very middle number. Now here's a little tip to kind of help you out. If you count to the n plus 1 divided by 2 value, that will give you the position of your median. So 9 plus 1 is 10. 10 divided by 2 is 5. 1, 2, 3, 4, 5. My fifth number here is 52. Notice that gives me 4 numbers below it and 4 numbers above it. So median equals 52, and these are incline angles of ramps, which means we're probably, not in degrees Fahrenheit, that would be weird, but just in regular degrees. Okay, the afternoon class, 1, 2, 3, 4, 5, 6, 7, 8, there are 8 values, okay? So if I'm going to use my little trick here, 8 plus 1 is 9. 9 divided by 2 is 4.5. 4.5 means the position of the median is between the 4th and 5th number. 1, 2, 3, 4, and then 4 and 5. So that's 4 values on either side of this median. So I would want halfway in between 57 and 58. Essentially what you're going to do is take that arithmetic average. So it looks like this, 57 plus 58 divided by 2. But when we look at that, we could just eyeball that. That is 57.5. Now remember that when we go to talk about two groups, if I wanted to compare these, it would be important to compare them using a comparison word. So I would say the median value of the afternoon class, 57.5 degrees, was greater than the median value of the morning class. The other thing I want to be able to determine in order to make a box plot is where the outliers are. The outliers, I'm going to need the interquartile range in order to figure those out. The other thing that interquartile range gives me is a measure of spread around the median. Now, we've talked about range from the biggest to the smallest value, but interquartile range is for me a way to say, here's where the middle 50% of the data is, and gives me a comparison value. Interquartile range is something that you need to have memorized. That is the difference between the third and first quartile. And the third quartile is the median of the lower half of the data. The third quartile is the median of the upper half of the data. Now, if you have your median as an actual data value, like up here in the morning class, where we were going to find the median, and the median was 52. When I talk about the median of the lower half, I am only looking at these lower 4 values here. So my quartile 1 would be halfway in between 49 and 49 in this case. All right, so let's go down here and find the interquartile range. It says state the 5-number summary and then determine if there are any outliers. Now, to find an outlier, what we're going to do is we're going to stretch that 50% of the box, and we're going to take quartile 1, and we're going to take minus 1.5 interquartile ranges, and we're going to take quartile 3 plus 1.5 interquartile ranges. One time I asked somebody in a meeting, I was like, why is it 1.5? And they said, honestly, the guy who came up with this procedure started off by saying, well, 1 was a little too few and 2 was a little too many. So it's just sort of a guideline here. So here are my numbers. They're in order. I notice there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 numbers. So if I think 12 plus 1 is 13, 13 divided by 2 is 6.5. I want in between the 6th and 7th number. 1, 2, 3, 4, 5, 6. And if I look from the other side, 1, 2, 3, 4, 5, 6. So my median is going to be halfway in between 6 and 7. So that would be 6 plus 7 divided by 2. So my median is 6.5. I could also go ahead and put in my minimum value of 1 and my maximum value of 30 here. Now, to find the first quartile, I'm going to take these 1, 2, 3, 4, 5, 6 values on the lower half of the median, and I'm going to cut those in half. So half of 6 is 3, so I'm going to cut that here. That means my quartile 1 is somewhere in between 4 and 5. So again, I would take 4 plus 5 divided by 2, and my quartile 1 is 4.5. Okay, similarly, I've got my upper set of the data, 1, 2, 3, 4, 5, 6. I'm going to cut that in half. Halfway in between 13 and 13 is going to be 13. So there is there's my 5-number summary. Now, to find that interquartile range, I'm going to take quartile 3, which was 13, and I'm going to subtract quartile 1, which is 4.5. Okay. When I do this, I end up with a value of 8.5. That is my interquartile range. So again, that's a measure of spread around the median. So when we're talking about SOCS, and you get to that spread comment, this is one of the numbers that you can use to discuss the spread of the data, because it says the middle 50% of the data goes from 4.5 to 13. It's 8.5 units long. All right, so my quartile 1 is 4.5. And I'm going to subtract 1.5 interquartile ranges. So that's 1.5 times 8.5. And I'm going to do this in my calculator. Remember, order of operations. If you type it in just like this, you should be fine. But that gives me, on the lower end here, that gives me a negative 8.5. Sorry, 8.25. Okay. On the upper end, I'm going to take quartile 3, that's 13, and I'm going to stretch that up by 1.5 interquartile ranges, so 1.5 times 8.5, and I'm going to pop that into my calculator. 13 plus 1.5 times 8.5 is 25.75. Now, if you have your calculator handy, then you should go ahead and make sure that you can compute these two numbers and you're not running into any sort of issue. Now, the idea then is this is like my outlier fence. So what I'm saying is anything that's between negative 8.25 and 25.75, okay, inside that fence, those numbers are okay. Those are fine. Anything that's outside the fence is an outlier. So on the lower end of our fence is negative 8.25. My lowest number is 1, which means that there are no low outliers because there are no numbers that are less than negative 8.25. On the upper end, however, this number 30, that is larger than my upper boundary, 25.75, which means that this 30 here, this is going to be an outlier. Okay, so we have a high outlier at 30. So if something ends up outside your outlier fence, it is going to be an outlier. Now, you can use your calculator to compute a box plot, and it'll pop the little outliers out as little dots, which is very nice and convenient. You can also compute it by hand using all of the numbers in the interquartile range. But sometimes you're going to need to know how this just works so that you can answer the question sort of theoretically. Given the 5-number summary, does the data set contain any outliers? Now, you don't have the actual data set here, okay, but what you do have are these summaries. So my interquartile range here, that would be Q3, 29, minus Q1, which is 25. So I have an interquartile range of 4. Okay, interquartile range of 4. So now I'm going to take my Q1, which is 25, and I'm going to go down 1.5 interquartile ranges, 1.5 times 4. Okay, and then I'm going to do the same thing for Q3. That's going to be 29 plus 1.5 interquartile ranges, 1.5 times 4. Okay, so in my handy dandy calculator here, or if you have your, you can do it in your head, it doesn't really matter. I'm going to take 1.5 times 4, that's 6. And 25 minus 6 is 19. So the lower end of my fence is 19. On the other side, I'm going to take 29 plus 6, and that gives me 35. Okay, so what I'm saying here is my outlier fence goes from 19 up to 35. So anything that is lower than 19 is going to be an outlier, and anything that is higher than 35 is going to be an outlier. So I'm going to compare that minimum value here to my lower end of this fence. Since the minimum value is 16, I know that the minimum is an outlier. But I also noticed that the quartile 1 number is 25. So there could be any number. I mean, 25% of the data is going to be between 16 and 25. So it could be any number in between there. There could be any number of numbers. So I don't know how many low outliers there is, but there's at least one low outlier, and there might be more. On the other end of this data, we have a maximum of 34, and this value goes up to 35. So if the biggest number is 34, there's not going to be anything bigger than 35. All right, so here I go. So what do I know? I know there is at least one low outlier of 16, and there may be more. Okay, so I know this, and I also know that there are no high outliers. Okay, let's do the same thing over here. So I've got my quartile 3 is 15, and my quartile 1 is 7. So if I find my interquartile range, it's going to be 8. I'm going to take quartile 1, that's 7, minus 1.5 times 8. Now, I almost don't even really need to calculate this fence because I know that it's going to be negative. And there aren't any numbers even in the negatives, so there's going to be no low outliers here. There's nothing that's going to be less than -5, so no low outliers. Okay. Do the same thing here with Q3. I'm going to take 15, and I'm going to go plus 1.5 times 8. Okay, so 15 plus 1.5 times 8 gives me 27. Now my maximum value is 30. So I know that there is at least one high outlier. At 30. Okay, and there may be more. Okay. I know that there's numbers could go from 15 up to 30. So if there's a whole bunch of 29s in there or something else like that, that would give me those outliers. All right, so we can find our 5-number summary, and we can compute our outliers. So now it's time to actually make a box plot. So to make the box plot, you are going to find the 5-number summary, determine if you have any outliers, and then sketch that box plot. Now I've already taken, and it says temperatures recorded in Mrs. Leahy's classroom for 2 weeks, and I've put them in order. So there are this is 14 numbers, so I'm going to cut them in half at 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so my median is somewhere in between 76 and 77. Okay, I know that my minimum value is, let me write this over here actually. Okay, so I know that the minimum is 62. Okay, I need to know what quartile 1 is. I know that the median is halfway in between 76 and 77, so my median is 76.5. My Q3 I need to know, and my maximum is 82. So there's the numbers that I need so far. All right, so I'm going to take this lower half of the data here. All right, lower half of the data, and I'm going to find the median of this. So half of the data just there. Okay, so 1, 2, 3, 4, 5, 6, 7. There's 7 numbers. So I am going to take the one in the middle, 1, 2, 3, 1, 2, 3, and 1 in the middle. That means quartile 1 is 75. I'm going to do the same thing with the upper half of the data. Okay, upper half of the data here. I'm going to look at this, halfway in between, 1, 2, 3, 4, 5, 6, 7. So I want this number here, 79. There's my 5-number summary. Okay. The next thing I need to do is I need to calculate this interquartile range so that I can check to see if there are any outliers. So the interquartile range would be 79 minus 75, which is 4. And then I'm going to check my outlier fence. So I'm going to take Q1, which is 75, minus 1.5 interquartile range minus 1.5 times 4. 75 minus 1.5 times 4 is 69. Okay. All right. So I have my values there, and I'm going to look. There's my fence, my lower end of the fence. Nothing can be lower than that. So this number 62, that is going to be an outlier. I'm going to do the same thing on the other side of the fence. Oh, this time, sorry, 79 plus 1.5 interquartile ranges. So Q3 plus that 1.5 interquartile range. When I do this, I get 85. And I look at the top and I don't see any numbers larger than 85, so I have no high outliers. Okay, so here we go. To make a box plot, the first thing you're going to do is you're going to draw a box that goes from Q1 up to Q3. So in our case, 75 up to 79. There's the box, 75 to 79. And then you are going to draw a line at the median, which is 76.5. Okay. I'm going to whisker up and whisker up to the largest number that is not an outlier, which in this case is 82. Then I'm going to whisker down to the largest number that is not an outlier, which in this case would be 73. And I'm going to put a dot at 62 for that outlier separately. Okay, so a box that goes from Q1 to Q3 with a line at the median. You whisker up to the largest number that is not an outlier. Then you whisker down to the largest number that is, to the smallest number that is not an outlier. Okay, so I'm going from 73. That outlier gets posted as that separate dot. Now, if I want to do this in my TI Inspire here, okay, so first off, I would start with making all my data in a document. So new document and data and statistics page. Okay, I have already entered in all of my data here. And the next thing I would do would be to add a page. I want a data and statistics page. You're going to use your cursor to drop your variable. I labeled mine as just X. Okay, but you could put temperature or whatever. There's my data. There's the dot plot. And I'm going to go plot type, menu, plot type. I'm going to change it to a box plot. You can see it's calculated that low outlier of 62. Okay, I've got 73 here as my lower whisker value. Q1 is 75, median 76.5, Q3 is 79, and the maximum value that's not an outlier is 82. So there's my box plot, and I kind of hover over those values and I can see those. Okay, so if you were going to asked to make a box plot of the data. You can line the data up by hand, just as mentioned. You can find all of these values, sketch your number line out. You can draw this by hand. It's perfectly fine. The other thing you can do is you can make a list in a spreadsheet. You can enter those values in any order. They don't have to be in order to do this. And you could make your box plot. Then to transfer this to your paper, you would create your number line. You would label it with your variable, which in our case would be temperature, and then hover over to figure out these values that you would use to construct that particular dot plot. And as long as that gets transferred over to your paper, that's fine. Remember, you still need to know how outliers work, because you may have problems where you're not going to be able to type in all the numbers to determine if something is an outlier, and you've got to use those formulas. All right, so last thing then, we can make a box plot, we can find outliers. If I'm going to talk about the SOCS, remember numerical data, we talk about the SOCS. One thing you need to understand is that box plots cannot show modality. So that means I cannot tell from a box plot if this data would be unimodal, bimodal, uniform. You cannot tell that. You cannot say that it looks approximately normal or that it's bell-shaped or anything like that. So what you can kind of make an adjustment for is shape in the terms of symmetry and skew, but you have to be very careful. So you should use words like the box plot suggests that it may be skewed to the left. Okay, so I'm going to take a look up at the picture that I just drew. So how do I decide from the box plot if it's skewed to the left or skewed to the right? So what I generally will do is I will take a look at the median value, and I will look from the median, there we go, median, down to the lowest value. And then on the other side, I will look from the median up to the highest value. And if it looks like the data is more spread out on the left, then it's going to be skewed to the left. If the data looks like it's more spread out on the right, it's going to be skewed to the right. So in this case, I would word, and I've got this down here, the box plot suggests, so I'm being very careful, suggests that the distribution of classroom temperature may be skewed to the left. And the reason why it's skewed to the left is because of that very low outlier. If that outlier hadn't been there, then we probably could have looked at this without the outlier and said, well, without that outlier right there, okay, it's a little bit longer on the right, but not like an immense amount longer on the right. So I could have probably called that roughly symmetric, or maybe very slightly skewed to the right. So I'm going to go with skewed to the left, again, because if I look at all the way down to the minimum, that's a lot longer. Due to a very low outlier at 62 degrees Fahrenheit. So I've addressed the shape and I've addressed the outliers. Notice I did not mention approximately normal or unimodal or bimodal or anything like that, because the box plot just shows these 25% spread ranges. The median was 76.5 degrees Fahrenheit. And then I want to talk about spread. Now, if you are using your median as your measure of center, you want to make sure you use interquartile range as your measure of spread. So I'm going to say the middle 50% of temperatures is from 75 degrees to 79 degrees with an interquartile range of 4. If you want to give the overall range, you can. That's perfectly fine and very appropriate. Okay, but the interquartile range in this case is generally a little bit more valuable than the actual ranges. Now, if I was comparing multiple dot plots together, or sorry, multiple box plots together, then I may want to comment on range if there's something interesting about that. You can also construct a box plot from a stem plot. First, notice that these are in order here. Okay, we've got these in order. So let's see how many numbers there are. Maybe. Apparently I'm going to use the purple pen because my other pen doesn't want to use. There we go. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So it looks like there are 31 values here. Okay, so if I think about counting to the 31 plus 1 divided by 2, I'm looking for the 16th number. I'm going to go ahead and write my 5-number summary down here. Looks like the minimum value, and the leaves are in order, thank goodness, is $45. I need to find quartile 1, I need to find the median, I need to find quartile 3, and I need to find the maximum. All right, maximum value is going to be $100. The median is going to be that 16th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so 71 is my median. Now, to find my lower quartile, I am only going to look at the numbers that are to the left of 71. Okay, so 71 is now excluded from that data. That's not included in the lower half or the upper half. So that leaves me with 15 numbers here. So I'm going to look halfway between those. I'm looking for like the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it looks like it's that 2 right there. I'm just going to double check counting the other way. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've got 7 on the left, 7 on the right, and the 8 in the middle. That looks like our Q1 is 62. I'm going to do the same thing from the other side. 1, 2, 3, 4, 5, 6, 7, 8. Looks like it might be that 76. I'm going to count the other way. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's the 8th number from both directions. That is 76. All right. So I'm going to find that interquartile range then. Interquartile range is 76 minus 62, which is 14. I'm going to look for that lower fence. I'm going to take 62 minus 1.5 interquartile ranges. So my lower fence is 41. Now my lowest number is 45, which means there are no numbers lower than 41, so no low outliers. I'm going to take Q3, 76, and I'm going to find 1.5 times the interquartile range. 76 times 1.5 times 14 is 97. So anything higher than 97 is going to be an outlier. So that means all of these 100s there, those are outliers. All right, so now I am ready to construct my box plot. So I'm going to come over, and I need my numbers to go from 45 up to 100. I'm just going to go by 5s. 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. And the variable here is cost in dollars. Okay, so cost in dollars. So I'm going to, no low outliers, I'm going to start off by drawing a box that goes from Q1 to Q3. So I'm going to draw a box that goes from 62 up to 76. And I'm going to draw a line at the median at 71. I'm going to whisker down to the lowest number that's not an outlier, which is 45. I'm going to whisker up to the highest number that's not an outlier. And remember we said that 100, there's actually 3 of those, 3 100s. I'm just going to draw 1 dot to represent their outliers there. The next number up looks like from the table that would be 88. Okay, so there's 85, 90, so 88 would be my other whisker. It says to describe the distribution. Okay, so I would do this in a complete sentence, but for the sake of notes, okay, so for the shape, if I was going to look at this, okay, here's my left, there's the right, okay, sorry, I said that backwards, but you guys see what I mean, okay, those look pretty close, okay, so I'm going to say that the shape here is roughly symmetric. So from the median to the edges of the box plot in both directions, those are pretty close, roughly symmetric. And I know that we have an outlier. We have a high outlier at 100. The center would be the median of 71. And the spread would have an interquartile range of $14. Okay. You could also mention the range in this case. If you wanted to, the range would be the biggest number minus the smallest number, which would be 100 minus 45 or $55 on these. Okay. All right. So what if you have to compare several box plots here? So I've already written this out. So I've got 3 box plots. It says compare the distribution of ages for female and male Oscar winners. So ages of winning actors 1975 to 2004. A, these are the female actors, and B, these are the male actors, and these are their ages. So the first thing I would do if I were you is I would go through and estimate what do I think the all these little numbers are. So you can see I've written above them. I think that's about 20, 32, 35, etc. Went ahead and calculated the range. The range for women seems to be going from 20 up to 80, so it's got a range of 60. Okay. The grab my highlighter here. Okay, the range of the men seems to be going from about 29 to 75, so it has a range of about 49. The interquartile range is the length of the box. That goes from 32 to 41-ish for women, that's about 9, and goes from 37 up to 51, which is about 14 for the men. Okay, all right, so I'm looking at the shapes. Both of these, if I go from the median to the left and I go from the median to the right, they both seem a lot longer on the right side. Okay, so I'm going to go through and talk about these things. I'm going to go through the SOCS. So I start off the distribution of ages. There's that variable. There's that context. For female and male Oscar winners, both have high outliers. So I'm going to mention the outliers here because they're very prominent. The females at 60, 70, and 80, using real numbers, and the males at 75. The box plots suggest, weasel, 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 that both age distributions are skewed to the right. Notice I didn't say anything about modality. No unimodal, bimodal, nothing, normal, any of that. The median for females was 35 years old. There's my center. And I'm going to compare them, is much lower than the median age for males at 42. So 35 to 42. So the median for women is much lower than the median range. So although the female range is greater than the male range, so range was 60 versus 49, the female interquartile range is smaller than the males of 14. So that's something that's interesting to point out. Now, you might say, so what? So what is happening here? So when we go to take a look at this, what I see overall is that it looks like, with the exception of a few female actors over the age of 60, overall, it looks like women are earning their Oscars at a smaller age than men are overall, with a very few exceptions. Okay, so after you get done with this, you might say at the end, so what? So what? We've got all this mentioned. So what? So overall, it looks like males win Oscars at older ages. This is evidenced by the larger mean and the larger higher position of the middle 50% of ages, from 37 to 41 years for male and from 32 to 41 years for females. Also, the majority of males were over age 40 when they earned their Oscar, where the majority of females were younger at age 40 years. Okay, so if you kind of look at this data, okay, here is 50%. 50% of the women were less than 35. 50% of the males were over 42. Okay, so it does seem like a lot of the males are earning them older than the women are. Okay, so this brings us to an important point. This is what the statistics are saying. This is what our evidence shows us. But what you don't want to do is go on a tirade about how Hollywood is sexist and that women don't earn Oscars because they're afraid to give Oscars to women who are in their older years and they can't get roles and all of that. Remember that on the AP test, one of the things you're doing is you are talking about the statistics, and don't ramble off on your opinion about the conditions of Hollywood. All right, so that is it for today. Good luck on Boxplots.